Welcome to Phenomenal Science, the journey of a researcher with Phenomics Australia, a podcast brought to you by one of Australia's top research infrastructure providers. Here at Phenomics Australia, we support researchers to discover the genetic drivers of human disease and enable high-impact healthcare outcomes in precision medicine. Through our nodes across Australia, we offer specialised infrastructure, research services, and technical expertise dedicated to advancing our fundamental understanding of health and disease. I am your host, Bridget, and I am currently studying cell and molecular biology and science communication. I have always been fascinated with genetics and how our lifestyles and environment shape us into who we are today. The interactions between our genes and our environment are what we focus on at Phenomics Australia to develop precise disease modelling tailored to individuals rather than a one-size-fits-all model. It is important that we can communicate the discoveries and impact of research to those outside the science community and educate and inform society on what we do. Phenomics Australia supports and guides researchers to pursue their passions through many ways we will discover as we follow the journey of researchers who are a part of our networks and use our expertise to conduct groundbreaking research into precision medicine. I would like to acknowledge the traditional custodians of the land this podcast was recorded on, the Ngunnawal and Ngambri people. We pay our respects to their elders past and present and recognise their continuing connection to land, water and culture. We also acknowledge the ongoing divide in equity within medicine and science with our Indigenous communities. Today I'm joined by Dr Simon Jiang, who is the leader of the Personalised Medicine and Autoimmunity group at the John Curtin School of Medical Research here at the Australian National University. He has been a long-term user of Phenomics Australia to further his research of precision medicine, with accessing many of our services, especially our histopathology node. Simon's research focuses on the genetic and molecular basis of autoimmunity and kidney disease. His lab leads a national personalised medicine program centred at the Canberra Hospital and ANU. Through identifying disease-causing genetic variants and cellular phenotypes, his research is able to treat complex autoimmunity in individuals. He is also leading research into understanding the causes of endemic kidney and immune disease in Indigenous communities across Australia. Hi Simon, how are you?
Good, thanks.
Thank you for joining our podcast today. It'll be very nice to get the view of an external user of our services and see how that has furthered your research. What inspired you to go into science in the beginning?
So thanks for having me on today to discuss my research journey. So I would say that my path into science, into research, has been a little bit more circuitous than the conventional path. So I was originally medically trained. So I trained as a kidney physician and still practice as a kidney physician. My inspiration to go into science and into research actually really was my experiences with patients as a junior doctor. So when I was training as a kidney specialist or as a junior on the kidney ward, I had a number of experiences with patients with complex kidney disease or really complex autoimmune diseases, where our ability to diagnose, understand what was going on with those patients, and therefore the limitations in our treatments really led to some bad outcomes with those patients, which I think left a very lasting impact on me. So very early in my career as a doctor, I realized that conventional medical practice was only going so far, and I think my desire to go into research stemmed from those experiences. One story that I do when people are like, oh, give us an example, was that when I was an intern or a resident, so just straight out, 1 or 2 years out of med school. And so again, I was undergrad, so I was a young, impressionable guy. And there's this really, really lovely, in her early 40s, had a kind of bad autoimmune disease. And then, of course, of the medication she'd been on, her kidneys, she'd gone into kidney failure and she had a kidney transplant, and then she'd had a hip replacement. So it's kind of pretty severe. She's 40, she's got a hip replacement, a kidney transplant. And then she came in and we, my consultant at the time was just, fantastic. I remember just spending a lot of time, like I'd go home and then I'd kind of look up, I'd be researching and trying to figure out what's going on. How can we figure out what's happening with this person? And she just got sicker. Like every couple of days, like things would just be a bit worse. And we're like, we're throwing all these tests and we're throwing different treatments at her. And we just could not figure out what was going on. And she was just getting sicker. And, it's really weird and unusual for 40-year-olds just to get sicker and sicker and sicker and sicker.
Especially when you're throwing more and more treatments.
Yeah,
and you'd expect them to get better rather than worse.
So that went on with this lady. It went on for, 3 or 4 weeks. And then at one point she landed in the intensive care unit because she just got so sick. And then she died. And I think it was this thing where I felt like I'd worked really hard, probably not well because I was a very junior doctor, so I had no idea what was going on really. But we just could not figure it out. Couldn't figure out what was going on. And I think that was kind of one of the really big ones where I was thinking, if only we had better tools or better ways, beyond kind of the very simple things. Medical technology is pretty good, but the truth is I think a lot of it is fairly reasonably crude things, and there's a whole world of science and technology out there that we never used or never couldn't try and use, and it would take 15, 20 years for people to adapt that and try and help people. And so, my big thing was there, and I'm thinking, so many patients come in, and I began to see it after that episode. I began to see it more and more and more, that there are so many people who would come in and say, it's probably just this, or it's probably just that. They're not really responding to this treatment. Oh, well, that just happens sometimes. And I think I used to think more and more that this kind of sucks. Why do we just keep letting that happen? Surely there is a way, people doing research, surely there is a way that we can do this better.
Yeah, why are we just accepting, okay, they're not responding to it, so we'll just keep throwing something out rather than trying to figure out why aren't they responding to it?
Yeah, well, and then we all, and I'm not like criticizing, I used to do it, and some days I still do it as a physician, but we will just go through this process of it's accepted that this is how we do it. Give them a treatment, doesn't work, we try another one, doesn't work, we try another one, doesn't work. And we're not actually really, we do a little bit to try and figure out why we got it wrong the first time, but we've got 1 or 2 tricks up our sleeves and that's it. And the people just get worse. And it's happened to my patients as well. But you just see that people just get worse because we wouldn't want to make that effort to try and...
It's easier to just throw the next medicine as well.
And it's a lot harder to get into research and really trying to hammer away at developing new ways that you can resolve these questions, really chipping away at big roadblocks. So the decision to kind of step a bit away from medicine is really realizing that there's a whole world where someone could just go across and understand a lot of those technologies and then try and bring back in and use those faster way to help people. Could probably do a lot of good and discover a lot of things that if you just took the effort to go and learn all these things that are not taught in conventional medicine, you might be able to bring it back and make some advances. So that was really my decision. I mean, I enjoyed research, but when you came through and realized you could do a whole bunch of other things, that was the big thing. So as I was getting towards the end of my training as a kidney physician, I realized that research would give me the opportunity or the ways in which to really get to the bottom of why people are unwell and make those differences so the things that I experienced as a junior doctor wouldn't happen again. So
more than just the treating, but also if you're a doctor, you're using the research that's established as the basis of what your treatments are. So to be able to actually get a deeper understanding of, okay, why are those treatments developed? Why do they look like they do? What is the fundamental basis of the kidney diseases that you're dealing with?
Yeah, exactly. So what will happen is, 7 times out of 10, that treatment will work. 3 times out of 10, it won't. And for some patients, watching probably the numbers are higher than that, they're just going through rounds of different treatments. And really what you're taking the most superficial understanding of what's happening to that person. And we're saying we're treating them all the same. And the problem is if the first round of treatment doesn't work, and then if the second round of treatment doesn't work, then a lot of physicians, including myself, we end up more or less trialing different things because we don't really have a true idea about what's happening. And so a lot of patients were falling between the cracks. The idea was that if we used all of the things that are available in a research environment to really get down to the nuts and bolts of why someone was falling unwell, by knowing why someone was so unwell, we would be able to intervene and make them better.
Rather than every new treatment that you do, there's yet another 6 months, 12 months of trialing that, seeing whether or not that's helping. So you're getting more time further and further and further from that initial diagnosis, which for some people can be critical.
Oh, exactly. Well, as time goes on, there's more injury. So, these things can leave lasting damage. The drugs that we use are often almost as toxic as the disease themselves. And really, often we will get to a certain point where we're just throwing different medications, for lack of a better term, at patients, almost out of desperation. It was kind of a flow-on effect where the treatment and the disease, when it's not being treated, people are getting worse and worse.
So you really saw that in your patients and then was like, I now feel like I would like to focus on more the research side so that we can get people better sooner. So in terms of that being like your motivation to go into research from medicine, now that you're in research, has there been any times that really spoke to you being like, yes, I did make the right decision?
I think when we set out, we were just first step in the personalized medicine journey was saying, can we identify or can we identify in an individual why they are unwell. Because again, when we're treating blindly, there is no personalised medicine. So when I was started branching into research, we were really just trying to understand, can we find why each person is unwell? The moments, I think the kind of standout moments for me was when we realised actually that yes, we are able to, at the first step, personalised diagnosis. The moments when I really started to think that this is really something much bigger than I anticipated was when we were also able to successfully treat people using that information. And I realized that we had the science, not in everybody, but a vast majority of people, to be able to give them personalized medicine or personalized treatments.
So seeing the success of your work actually more than being just a novel idea of being like, okay, we think that making a personalized medicine should help that individual, but to then actually see that medicine be successful in the initial stages of this.
Yeah, well, I think at the start it was an idea, a nice idea, and I think it's an idea that we talk about a lot and worldwide, globally. And so I, like most other researchers and physicians, thought it's a pretty cool idea. It'd be great if we could do this. I was first excited when we were able to find things that were wrong on an individual level. The thing that really has excited me the most is being able to make people better, that had failed multiple rounds of treatment, and being able to improve their lives using kind of a method of an approach to medicine that hasn't been used before. And that's the part that I think really excites me the most, that we're able to accomplish things that I didn't actually think, being honest, we would be able to accomplish when we set out. A really good example in terms of that impact. So I had a patient who had been, as I say, 10 years, complex immune disease, autoimmune disease, that he's seen like about 4 or 5 different physicians, been on about 7 different agents, he had so many different treatments that his bones are really brittle. He's essentially wheelchair bound. He's in hospital about 4 or 5 times a year. And then we took him through the personalized medicine program, identified what we think is the gene that was causing his illness, created the mouse, showed treatment, and now he's kind of coming in. He comes and sees me still clinically and comes in with gardening injuries because he's out of his wheelchair. He hasn't been in hospital for 12 months. He's got a life, right?
Things,
He's essentially hospital bound for 5 or 6 years. And once we figured out what was going on, he's just out and about.
How quickly it's like once you get it right, the improvement can be
huge.
Exponential.
Yeah. And he's on kind of $5,000 a pop in treatments for, and now he's on a tablet, which is about 60 cents a week or something like that. Yeah. And then his quality of life is through the roof.
His quality of life is so much better than what it was before. And especially just like thinking that he had to go through those 5 or 6 years of being wheelchair bound to get to where you are, and then hopefully in the future, you'll get there faster as the industry grows.
Well, again, we found he had one gene that was affected. Found there was another 7 people in Canberra who had different mutation in the same gene, and we were able to treat them from what we had learned in him.
From what you learned.
And so we've been able to use personalised medicine and take all those lessons. He went through a hard yards kind of thing. And then all those personalised insights, we're then able to adapt those into other people who had a similar process. Because the type of thing as we understand more about it, that body or kind of library of knowing specific genes and specific processes and specific treatments will grow and grow, and we'll be able to increasingly personalise medicine for people with these illnesses.
And our ability to help people who may not have been able to be helped before and really change lives for the better.
That's the dream.
That is the dream, change lives for the better. Better our health overall. So with your program that you run at the Canberra Hospital, in terms of like the patients that you're working with, is that someone who has failed the initial round of just using the generic medicine for your kidney disease and then they come to you, or what is that process?
So at the Canberra Hospital and also from around the country, so we get referrals from most metropolitan cities around Australia, and we have a handful from international centres. Generally speaking, physicians will refer for a few different criteria. So one is if someone's failed their first or second line, and the physicians generally get an idea based on how severely unwell somebody is, that this might be someone who conventional treatment is going to be difficult. So if they have a patient comes in who's very unwell, they might reach out and say, look, this is very unusual, it's very severe. We might want to start working them up just in case the treatment doesn't work. They may also, there are other instances where they'll come back and say, look, we've tried 2 or 3 different things and I need a bit of help to see, is there something here you can identify that we might be able to treat? The other one is when the physicians think that there's a family illness, in which case the chance that we're going to find something is a lot higher because everybody's affected together. So those are generally the three types of people that are really treatment resistant, very severe disease, or if there's within the family.
You have like a genetic history sort of thing.
Yeah.
I also see that your research, you're working with Indigenous communities as well here at the ANU with
NSIG.
Is that something that's very new?
Well, we were brought together through one of the ANU Grand Challenges into Indigenous health and wellbeing. And so the reason that we were brought together, and it's actually been a very successful or fruitful collaboration, we initially were working with the Tiwi Islanders. So there had been a group at the John Curtin and with NSIG who had realised that in the Tiwi Islands, just off the north coast of Darwin, they have the highest rates of kidney disease reported in the world. So, it's about 4 times other Indigenous populations in Australia, and their rates are maybe about 11 times or 10 times that of non-Indigenous Australians. And so they've got the highest per capita rate anywhere. So because I'd been doing so much work on personalised medicine and the genetic cellular cause of disease, the very simple question was, can you apply that approach almost at a population level, and can we identify what could be causing so much kidney disease in the Tiwi? And we have found not just one, but 15, 16 different genes that are highly mutated, which are unique to the Tiwi, which are increasing their risk of kidney disease. And it also, the implications of it is we found that probably how we treat kidney disease in these communities are different. So NSIG is right at the forefront of the vanguard. So even when we talk about what is a normal human genome, those are really from studies done in Europe and North America.
Yeah, very European.
Yeah.
They've got that inherent bias.
Exactly. And so there's been no real studies of what is the difference between people who've been geographically isolated from those studies for tens of thousands of years. No reason why they should be even close to being genetically similar to, and therefore responding the same as people in other countries.
Therefore, your work is very crucial in ensuring that from a medical point of view, we're not increasing the inequity and the inequality in our medical sector. Looking to your research, you have a lot of different projects that you're involved in. How did you discover Phenomics Australia, and how do we help you further the amazing work that you're doing?
So I use discover Phenomics Australia, I think, is searching for resources with which to do my work. So the areas which I use Phenomics Australia specifically in is when we find a gene, which is a mutation in a gene, and we think this is going to be causing disease. What we do generally when we think that this is a pathogenic mutation is we will generally try and create a mouse model. So mouse models allow us to study how does a gene affect a whole organism. So making mouse is highly specialised, it's fairly expensive, and so Phenomics Australia has several nodes around Australia who do the gene editing to create these mouse models of human disease. So my first interaction with Phenomics Australia was really around accessing their CRISPR mouse services, and I currently work with a few nodes around Australia, but right now it's probably with Monash. When those mice come through, so it's relatively sporadic, and it's not the type of thing that we kind of have like a dedicated facility where we're just, we're not having a mouse made every week or so. So there's kind of a full-time staff just located at the ANU. So for highly specialized services, having kind of a centralized node where they will have enough throughput means that we can access specialized services, without the horrendous expense of trying to have sustain something like that.
Trying to have to establish your own
process here at the ANU.
At the ANU. It's not economically feasible.
No, it'd be economically insane, probably.
So to have that access to our nodes that are able to provide you with that service is really crucial.
Yeah, and so it's quite well subsidised. They've got a high level of expertise because they're receiving inputs from Monash's case, Melbourne and other centres. So they maintain a level of expertise because there's a high throughput and requests, and it means you can access that experience and high level of service without having an exorbitant cost, which then eats into your other research funding. Mm-hmm. I suppose the other part of it is that when we come out, kind of in a similar vein, is when the mice come through, we don't know what we're going to get. We anticipate they'll have a certain type of illness. We often use the pathology services in Phenomics Australia, where they've got specialised expertise in analysing, doing necropsies. So they're actually analysing the mice and seeing what type of disease are they developing. Is it similar to the patient's or the Tiwi's kidney problems? So again, it's the same thing where, specialized mouse pathology services, the amount of mice that you're going to be sending through in a single center is not huge. So having that economy of scale where you've got a lot of people coming through, a lot of groups from around the country coming through highly specialized centers means you maintain a very high quality. And because that center is having high volume, it means that we're not spending huge amounts of our budgets to support a level of expertise when cases are just trickling through.
And how histopathology and our pathology nodes know what they're looking at and have done this extensively. Also that level of trust that you know that when you're using the services, the quality of results and the quality of service that you're going to be provided with is high enough that it will be very beneficial to your work.
Yeah, look, and I think a really good example is even for myself. I've seen a lot of kidney slides as a kidney physician's human slides. So when our first couple of models were coming out, I looked at the slides, the histo slides from the mice, and I was thinking, there's all these kind of weird abnormalities on there. I think we've found all these things. But, obviously, mouse kidneys don't have to look anything like human kidneys. And so when you kind of go through someone who's has that high level of expertise, has seen a lot of mouse kidneys, which I haven't, they'll say, no, these are all just, these are normal levels of variation. These are not, these are not pathological. And when something pathological came through, it's clearly something we haven't seen before.
Yeah, with their digital slide scanning, how beneficial that they're able to sit down with a researcher or with a user and be like, okay, this is what we're looking at, because they do have that technical expertise. To be able to look at it and, okay, this is normal, this is abnormal, this is where we should go. Also providing the guidance as well of not only a user coming in being like, can I use your services? I'd like to use them, but also having that expertise from the node side of view.
Yeah, and so again, I think that's a crucial point, is that some of these things are so specialized, you need to have centralized expertise, because otherwise a little bit of knowledge is not enough really to function at a high level. And some of these models that are coming through and some of the research that you're doing, you need to have a high level of expertise.
To have that level of expertise is super crucial in doing work that is very significant. We've told this person we're going to try and help them find a medicine for them. So do you see this industry increasing? I know that you're working with kidney disease, but do you see, for accessing Phenomics Australia, that personal medicine is an increasing industry?
Yeah, for sure. There's no doubt. I mean, the growth in requests for access to the technology, as much as the insights, I think we tie in a lot of education back for clinicians into the work that we're doing. And as people become more skilled in understanding, how can genomics actually tell us something about what's happening to my patient? Can phenomics tell me something about what's happening to my patient and that I can act on it? As that insight and that understanding is increasing, means that there's more referring. So saying, well, I know that I've got this whole suite of technologies or approaches which I've never used before. If you're aware that it's there and it can be accessed, then people are referring much more. Again, even with PA, with mouse generation, we have gone from 1 or 2 every year, and now we're kind of in this process of where we're ordering multiple lines of mice and kind of accessing pathology more. I think for personalised medicine and that approach, it is growing, and I think it will only grow more once we realise more and more how effective it actually can be.
That shows the opportunities that were made possible by having access to Phenomics Australia and working with the support that we can give you. Without those services, would your research be as successful?
Well, I mean, the mice are a huge thing. I mean, the genotyping, we could do, but it would be slower and much more resource intensive. So again, it's a matter of efficiency. But there's no question that for mouse generation, it often will be the big breakthrough. I mean, once we can do some very simple tests to know whether a mutation is damaging or not. But if we really understand what's happening to the patient and therefore how to treat them, the mice are really quite crucial to that. We wouldn't be able to sustain that facility by ourselves. So having that centralized resource, the flow on effect from using understanding what's going on with these mice is quite significant, and it's crucial.
So not only just helping your work, but also helping the industry overall, and raises awareness of how useful a mouse model for human disease and how it can be applicable more than just kidney disease.
And I mean, the mice that we have, we're actually testing them before going to the patients. We can actually trial the drugs that we anticipate are going to work. So they're beneficial for the patients, and then they're beneficial for other patients who have similar mutations or similar processes.
Just looking at how successful your research has been, what has made you the proudest of not only in your career as a physician and a doctor, but also now looking at the research side and creating the personalised medicine that physicians now use?
Look, I think there are a few things at this point in time which I'm grateful and I'm fortunate have happened. One is my lab. It's actually it's full of just really good people, like good people who do work very well in a team. And I think a lot of the work they do for the right reasons, very motivated around helping people and trying to understand what's going on so we can help individuals. You know, for me, in terms of the research, as I said before, the thing that I'm, I guess, most proud of, for lack of a better term, is that when I started out on this idea of trying to understand what was happening with people, I thought it was more kind of science fiction that we'd be able to take it as far as we have would be like science fiction. The fact that we've managed to actually go as far as we have is kind of, you know, for someone who's been trained clinically, where we've gone on the research side of things, how far we've been able to translate that back into clinic and actually transform people's lives is the kind of thing that I'm kind of, you know, amazed that we've actually been able to do what we've done and that it actually works, the kind of idea works. So the fact that, you know, I get to work with a very good team and that we've actually been able to use an approach which is not really used anywhere else to actually make people a lot better when conventional therapy has failed, I mean, that's the thing that I am most proud of.
And the most rewarding in terms of knowing that you are able to help people who, say it was 10 years previously, would not have been able to get the medicine.
Well, that's right. And I think when you think about it, what is the absolute proof? We do a lot of research where we kind of figure out what's a biological process or what's a new discovery about this thing does this to a cell, but what's the absolute proof for me that you're on the right track or that you understand what's happening? And that's if you try and alter it and someone gets better. At the end of the day, if you've determined that this appears to be what is causing someone to be unwell, and you say, I can intervene this point, and then they get better, that to me is really the ultimate proof that you're on the right, that you've gotten to the crux of what the issue is.
Do you think you would go back to being a physician full time now that you have experienced the research world?
No. It's a constant tension. I mean, there's no way I could go back to routine clinical work, I think.
You're just enjoying your work too much, and
yeah, I mean, I'm looking for ways to get into the laboratory, you know, increase my time in the laboratory and in the research. Again, I feel like I can do more for people here and around the world in the laboratory than I can in my clinic. Not saying that I enjoy my clinics. I have a lot of good patients and I have good relationships with them, but
it's the actual development of those disease models and the development of the treatments that you know will be most rewarding, because that's what helps the most people, doing more than just being in that clinician role.
So if you can understand the process that affects thousands of people, help thousands when you're one-on-one day-to-day in clinic.
It sounds like you're doing amazing, fabulous work that goes definitely over my head. To be sitting in front of someone who is helping thousands and thousands, and not only helping just your general people, but also really furthering our medical research for Indigenous communities as well, which is quite crucial in Australia. Lower the inequality and the inequity that we have from having European biased medicine at the moment, to be able to develop new disease models and new treatments that will help more people than what they were helping before. I'd be very interested in hearing more about the work that you're doing for Indigenous communities, and in terms of like the genetic basis. I have connections up in Arnhem Land, so above Darwin, and family up there. So more about that.
I mean, again, that's like you were alluding to when you're saying outright that personalised medicine is a growing field. You know, even this space in Indigenous health is a growing field as well. So, we started with working with the Tiwi and have found that the processes that are driving kidney disease in the Tiwi are different to any other population on Earth, which is probably why their rates are high. And our working hypothesis around what's happened is that they have, as you would anticipate, they have adapted genetically to land. And that old thing where they say that, a lot of communities say that we are relating to our land. In many ways, I think you're seeing scientifically evidence that genetically they have adapted to land. So that there is a connection between land for the Tiwi and the island. The problem is that when Europeans came in and they introduced European illnesses and European diets, is that the Tiwi were not adapted for those lifestyle influences and those infectious things that came from What are the reasons why there are health disparities that are outside of the things we say, oh, it's just because of, access to healthcare services and all those kind of things.
It's more of like when you have the concept of environment versus genetics, but their environment has been the same for tens of thousands of years, and within 200 years, it has been completely changed. Is there a human genetic basis in Indigenous communities in terms of the way that they have dealt with disease and what their thousands and thousands and thousands of years of disease look like?
There are really well-established examples where when you take a population out of their environment, something goes from being good to being very bad. And you take that person and that gene out of that environment and put it into another environment, and it goes from protecting them to making them predisposed to getting unwell. And it's that delicate balance between what's good and bad for you. You take away what's bad or you introduce something that's bad. We're no longer adapted for that, and things can spiral out of control.
The need for personalised medicine is really becoming more and more crucial when we're starting to realise what the environment does to our genetics.
Yeah.
And really realise how crucial it is that it's not just one medicine will suit everyone. It is really crucial that we look at our different populations so that we better the health of everyone.
Prevention's better than cure.
Exactly. And you're one of the ones who are clearly doing fantastic work.
Trying.
In that and improving our health overall.
What I do pinch myself. Like, this is, as I said, like, to me, and I'm at the guts, kind of right at the edge of all of the personalised medicine, developing pathway, new ideas about how we're going to do it and improve it and all this, which is a weird place to find yourself. But actually, it was a dream or an idea, and to actually find yourself there and doing it and actually being successful, like it is like that, where it's quite trippy. Like for me, you're focusing on this idea of what can you do, and at some point you kind of look up and you realise that you've actually done all this stuff, these things that you never thought you'd be able to do, and it's a bit trippy.
What advice would you give to someone who maybe is a physician who's thinking of doing research, or you're a future researcher who's thinking of going into medicine, or someone who is stuck?
Which one do I start?
Which one do you start with?
Which one do I start with? Find something that you're passionate. So, I mean, I find something you're passionate. I know it's a trope, but sometimes it's hard doing research. Often it's hard doing research, long hours, a lot of difficulties with funding and things like that. And I think it's crucial that the people are passionate, that they love, they're motivated by something, that there's, for me, an idea about something that you're trying to do, and that motivates you to move forward. If it's just completing a project, that's okay. But if it's something even more, then I think it's very easy to be motivated and to be passionate and to kind of pursue that. And I'd say in general that they should just pick environments where they're well supported, that they are enabled to do good research. Because otherwise, if there's no one to support you and not a good environment, it's very easy to just waste a lot of time doing things that are not very productive. But again, I think if you're an idea about what your research means, and so for me, it is almost like a new way of doing medicine, and helping people that are otherwise, there's not really any opportunities. The research, I think, you tend to be motivated to a very clear outcome, which someone's going to benefit from. And I think inevitably, because you're wanting to pursuing that clear ideal, I think the work generally flows into it. Good research comes out of that when you've got a very clear outcome that it's going to be of benefit.
And if you're coming into roadblocks in terms of resources, definitely look to Phenomics Australia and see whether or not one of our services can help.
I have turned to PA for things like accessing that expertise. As I was saying before, with the mouse models, and they're expensive because they're high level. But I think the really big discoveries need a high level of expertise and a high level of technology. So engaging with those processes will actually lead to stronger research questions and better discoveries. And so accessing those high-level skill sets. So that's why we go to pathology, because those things really open a lot of doors in terms of figuring out what's happening with the patients, understanding how that's actually making people unwell in my instance. So, accessing those specialized services will open doors which people may not even be aware of, or opportunities to understand whatever it is they want to understand, and they may not be aware that these models exist or these technologies exist. Getting insights into people about those platforms, ones like that the PA have, I think it's crucial to come pushing forward, pushing the boundaries of the research that you're doing.
And supporting Australia as a whole, and supporting everyone who is trying to better precision medicine and not a one-size-fits-all model. One medication is going to fit for absolutely everyone. Thank you.
No, you're welcome.
That was wonderful.
I hope it was helpful.
No, that was really, really interesting. That was fantastic. I really enjoyed that. Thank you for tuning in to Phenomenal Science, the journey of a researcher with Phenomics Australia. With each episode, we explore new aspects to the groundbreaking work of our phenomenal researchers and uncover the tremendous impact of our research on science and society. Listen in as we dive deep into the world of phenomics and innovation, and continue to follow us as we embark on this remarkable journey together. I would also like to thank the Australian National Centre for the Public Awareness of Science, CPAS, for providing the amazing podcast studio we are recording from, and all those who we have interviewed for their insights into Phenomics Australia. We look forward to hearing from our next researcher and guest.